Hi everyone and welcome to Sums of Anarchy Let's Solve. In this video we're going to be working our way through the Edexcel higher tier non-calculator maths paper from 2021. I hope it's easier than remembering the title of the paper. We'll pop a link in the description if you want to download that for yourself, but let's jump straight in. Okay, question 1a, we've got some decimals here. Work out 3.67 times 4.2. Now, when I'm multiplying decimals, the thing I like to do first is just round them to the nearest whole numbers and take a quick estimate, and we'll see why in a minute. So, estimate, I'm going to round 3.67 up to 4, and I'm going to round 4.2 down to 4. Now, this isn't going to be an exact answer by any means, but it will help us a little bit later. So 4 times 4 is 16. I'm just going to leave my estimate there. Okay, so what we do next when we're multiplying decimals is we just ignore the decimals for a minute and we multiply as though they were just whole numbers. So we're going to do 367 times by 42. So that's just ignoring the decimals completely for a minute, and we're going to proceed with long multiplication. So we start at the right, 7 times 2 is 14, we write the 4, we carry the 1. 6 times 2 is 12, plus that 1 gives 13, we write the 3, we carry the 1. 3 times 2 is 6, plus that carried 1 gives 7. Alright, we're finished with the 2, let's just get rid of these carried numbers. Lost half the 6 as well. Okay, now we're moving on to the 4, which is actually a 40, so I'm going to put a 0 in the units column, then we can treat it like it's just a 4. So 7 times 4 is 28, so I'm going to write the 8, carry the 2. 6 times 4 is 24, add the carried 2 makes 26, I'll write the 6, carry the 2, and finally 3 times 4 is 12, plus the 2 gives 14. So the final step of the long multiplication is to add these numbers. We'll start at the right, so we've got 4 plus 0 is 4. 3 plus 8 is 11, we write the 1, carry the other one. 7 plus 6 is 13, plus the 1 is 14, write the 4, carry the 1. 4 plus 1 is 5, and then we've just got a 1 at the end. Now, if we look back to our estimate, we can see that we worked out that the answer was going to be somewhere near to 16. So already I can look at this. Right now it says 15,414, so it's definitely not going to be that. But if our estimate gave us 16, that means I can already tell that the decimal point is going to go here. The answer that's closest to 16 would be 15.414. But another way of knowing where to put the decimal place is you add up the amount of decimal places in each of the numbers that you're multiplying by. The answer will have the total amount of decimal places. So in the first number, the 3.67, we have 2 decimal places. In the second number, 4.2, we have 1 decimal place. So that means that our answer will have 2 plus 1, which is 3 decimal places. And as you can see here, it does have 1, 2, 3 decimal places. Now, why is that the case? Let's just quickly have a look. Well, if I put the decimal points back into this multiplication, so that would be here and here. What did I have to do to 3.67 to get 367, which is the number that I used in my multiplication? Well, I'm just going to remove these carried numbers for a minute. Well, I had to multiply by 100, so that meant moving the decimal place out the way by moving it 2 spaces to the right. The same for the 4.2. In order to make it a 42, which is what I used in the multiplication, I multiplied by 10, which moved the decimal place 1 place to the right. So in the first number, I multiplied by 100 to turn the 3.67 into a 367. So that moved the decimal point 2 places to the right. And in the second number, I multiplied by 10, which moved the decimal point 1 place to the right. So overall, I multiplied by 1,000, which means for my answer, I need to divide by 1,000. So that means moving the decimal place, which would be here at the end of the whole number, 3 places to the left, indeed giving me 15.414. Okay, question 1b, dividing decimals this time. Work out 59.84 divided by 1.6. Now I'm going to start again with my estimate. So I'm going to round these to the nearest whole numbers. So 59.84 becomes 60 and 1.6 becomes 2. Now 60 divided by 2 is 30. So that should give me a ballpark answer when I've finished my division to check. Okay, now what we want to do here is we want to divide by a whole number. It doesn't really matter if the dividend is a decimal, as you'll see in a minute, but we want to make sure we're dividing by a whole number. So how can we turn the 1.6 into a whole number? Well, we can multiply it by 10. That will move the decimal point one place to the right, and it will give us 16. But if we've multiplied the 1.6 by 10, we have to multiply the 59.84 by 10 as well. So again, it's going to move the decimal point one place to the right. So what we're actually going to do is 598.4 divided by 16. So what we've done here is we've multiplied both numbers by 10, and we can do that and we'll have the same answer. So now it's just a case of long division. So 598.4 divided by 16. And the first thing we're going to do is put in the decimal point because it's going to take the same position in the answer as it did in our dividend. Okay, so before we start, I'm just going to write out the 16 times table at the side because it's going to help me with this division. So we've got 16, 32, 48, 64, 80, 96, 112, 128. That's probably enough, I think, for this multiplication. So we've got that on hand for when we need it. All right, so now back to our long division. So first things first, does 16 go into 5? No, it doesn't. But does it go into 59? Yes, it does. How many times? Well, we've got our 16 times table at the side here, so we can just count up. It goes 1, 2, 3. We're not going to make it to 64, so it goes in 3 times with a remainder of 11. That's the difference between 48 and 59. So I'm going to put the remainder in here next to the 118, next to the 8, sorry. Okay, so now how many times does 16 go into 118? Again, let's use our times table at the side. So we've got 1, 2, 3, 4, 5, 6. It goes in 7 times with a remainder of 6. That's the difference between 112 and 118. So 7 times with a remainder of 6. I'll carry the 6 over to the 4. And finally, how many times does 16 go into 64? Well, it's on our list there. 1, 2, 3, 4. It goes in 4 times exactly. So our answer is 37.4, and we can see from our estimate that it had to be somewhere around 30. It wasn't going to be 300 or 3,000 or 3, so 37.4 does make sense. All right, question 2. Complete the Venn diagram for this information. Okay, so we've got some sets here. What sets are groups of things. Much like a badger set, 2 T's, is a group of badgers. Here we have some groups of numbers. So firstly, we have got this fancy looking E here, which just so happens to be the Greek letter Xi, which stands for the universal set. So that is all of the numbers or objects that we're interested in for this question. So that is the even numbers less than 19. Then we've got set A, which is just the numbers 6, 12 and 18. And we've got set B, which is 2, 6, 14 and 18. So now we've got this Venn diagram. The circle on the left represents all of the numbers that will fall into group A. The circle on the right represents all the numbers that will be in group B. And the overlap in the middle is any numbers that happen to be in both groups A and B. Then we've got the outer rectangle, which represents everything else that's in our universal set, but not in A and B. So we should start by working out what is in our universal set Xi. So let's draw this. Oh, that's a rubbish. Fancy E. Let me try again. I'll just go for a normal E. All right, so even numbers less than 19. So we will include 0 as an even number less than 19. 2, 4, 6, 8, 10, 12, 14, 16 and 18. So that's all the numbers that are in our universal set. So now let's have a look at Let's start with the numbers that are in both A and B. So firstly, we've got 6, that's in both A and B, and we've got 18. So if those numbers are in both A and B, they're going to go in this overlap here, 6 and 18. And I'm going to cross them out of our group here to know that I've already included them in the diagram. Okay, so now I'm going to look at what numbers were in A but not in B. So that's just one number left, that's the 12. So that's going to go in this part here. And what numbers were in B but not in A? So that was 2 and 14. So that's going to go in here, 2 and 14. So I can cross out 2, 14 and 12, which was in A. Okay, so all of these numbers that are left, they are part of E, but they weren't in A or B. So I'm going to write them into the box, but outside of the circles. Now, we'll make it easy for the examiner and we'll put them in order. 0, 4, 8, 10, and 16. So just a quick count up to check that we've got all of our numbers. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, question 3. Work out 4 1/5 minus 2 2/3. Give your answer as a mixed number. Okay, so these are mixed numbers to begin with. They are made up of whole numbers and fractional parts. But if we're doing a subtraction, what we want to do is turn them into improper fractions. So those are the ones that are top heavy, where our numerator is bigger than our denominator. So how do we do that? Well, we do the whole number times the denominator plus the numerator over the denominator. Now, if that sounds like a bit of a mouthful and you struggle to remember it, what you could always do is just work out an easy example. So for example, you could try 3 1/2. Okay, and now what we're going to do is we're going to draw some circles and split them into halves. Excellent circles. All right, so now we're going to colour in 3 1/2. So for 3, we've got all of that one, all of that one, and all of that one, which is 3 wholes. And then we've got an extra half. Okay, so now let's count up how many halves we have. Well, we've got 1, 2, 3, 4, 5, 6, 7 halves. So that's going to be 7 over 2. Now, what did we do here? Well, in each of these full circles, we had 2. So that was 3 lots of 2. So there you get the 3 times 2. Then we added on just this one single half. So that was adding on the numerator. So if you ever forget the formula for turning a mixed number into an improper fraction, just draw yourself out some circles for a simple example and see what it is you did there, and then you can apply it. So going back to our question, we're doing the whole number times the denominator plus the numerator over the denominator. So let's do that for 4 1/5. So the whole number is 4 times the denominator. 4 times 5 gives 20, plus the 1 makes 21. Let's do this in blue. 21 over the denominator, which is 5. Okay, let's do the same again for 2 2/3. So we've got the whole number, that's 2, multiplied by the denominator. 2 times 3 gives 6. Add the numerator, 6 plus 2 is 8 over the denominator. Okay, so now we've got a subtraction with improper fractions. It's going to be much easier. We've got to do 21 over 5 minus 8 over 3. So what we're going to do here is we're going to multiply diagonally. So 21 times 3 gives 63. 8 times 5 gives 40. So it's 63 minus 40. And then we're going to multiply the denominators. 5 times 3 is 15. 63 minus 40 is 23 over 15. Now remember, it did ask us to give our answer as a mixed number, and what we've got here is an improper fraction. So let's have a look how we go the other way. So what we have to do is we have to do 23 divided by 15. So that's the numerator divided by the denominator. So what does that give us? If we do 23 divided by 15, how many times does 15 go into 23? Once, remainder 8. So our answer is going to be 1 and 8 over 15. Now again, if you forget how to do this, you can always draw some circles. So we've got 23 over 15. So if we draw 2 circles and we split them into 15 parts, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, getting smaller, 13, 14, 15. Okay, I should just duplicate that. All right, so we've got 2 circles with 15 parts. Now, if we've got 23 over 15, let's colour in 23 15ths. So we know that in the first circle, we're going to colour all of those. It's going to be 15 of them. So the whole circle gives us 15 parts. And now let's keep going. 16, 17, 18, 19, 20, 21, 22, 23. So now we've coloured in 23 15ths. How many did we colour in? Well, this one gave us 1 whole. And this was 8 15ths. So there we go, 1 whole and 8 15ths. So if in doubt, you can always rely on a picture. Okay, question 4. At the end of 2017, the value of Tamara's house was £220,000. The value of Raheem's house was £160,000. At the end of 2019, the value of Tamara's house had decreased by 20% and the value of Raheem's house had increased by 30%. At the end of 2019, whose house had the greatest value? You must show how you get your answer, probably because otherwise we'd have a 50-50 guess. All right, so what do we have to do here? We need to work out the value of Tamara and Raheem's houses at the end of 2019. So let's see what happened. Tamara's house decreased by 20%. Now what we could do here is we could work out 20% and then subtract that from the original value. Or we could jump straight to calculating 80%, because if our house decreased in value by 20%, it's now 80% of its former value. So let's write Tamara, 80% of 220,000. And the same goes for Raheem. His house price increased by 30%. We could work out 30% and then add it on, or we could go straight to calculating 130% of the original value. So 130% of 160,000. So these are the two values that we are looking at. Let's start with 80% of 220,000. Let's go over here. 80% of 220,000. Okay, so one way that we could work this out is 80 over 100, that's 80%, 80 out of 100, that's what percentages mean, times by 220,000. Okay, so we can cancel out some zeros from the denominator here and this numerator over here, and we're left with 80 times 2,200. Now, when we're multiplying numbers that end in 0, what we can do is we can ignore all the zeros to begin with, we'll do the multiplication of what's left, and then we put the zeros back in at the end. So what's left is 22 times 8. So 22 times 8, we can do some long multiplication. 2 times 8 is 16, 2 times 8 is still 16, plus the 1 is 176, and then those 3 zeros that we ignored, we have to put back in again. So that's 176,000. Okay, so that's one way of doing it. I'm just going to show you another way of working out 80% of 220,000. When you have to work out a percentage and both of the numbers end in 0, you can ignore the final zeros and multiply. So you can just do 22,000 times by 8. We just ignored 1 0 on each number. So now 0 times 8 is 0, 0 times 8 is 0, 0 times 8 is still 0, 2 times 8 is 16, 2 times 8 is 16, plus the 1, 176,000 again. Okay, so now we know that Tamara's house is now worth £176,000. Let's work out the value of Raheem's house. So we have to do 130% of 160,000. So 130% of 160,000. Make sure I've got enough zeros. Yep, that's fine. Okay, so 130, we'll do the first way of doing this. 130 over 100 times by 160,000. Again, we can cancel some zeros here. And now we've got to do 130 times by 1600. But again, when you're multiplying numbers that end in zeros, you can temporarily ignore the zeros, multiply what's left, which is 13 times 16. So we've got 3 times 6 is 18, write the 8, carry the 1. 1 times 6 is 6, add that carried 1, makes 7. Now we put a 0 here, move on to the 1. 3 times 1 is 3, 1 times 1 is 1. And finally, a bit of addition. 8 plus 0 is 8, 7 plus 3 is 10, carry the 1, 1 plus 1 is 2. But we ignored 3 zeros, so we put 3 zeros back in again. So 130% of 160,000 is 208,000. So let's add that in for Raheem. And it turns out that Raheem made the better purchase because his house is now worth more. Okay, question 5. Rosie, Matilda and Ibrahim collect stickers. Okay, so we've got some ratios here. So ratios represent quantities. They help us to compare quantities. So we know that the ratio of Rosie's stickers to Matilda's stickers to Ibrahim's stickers is 4 parts to 7 parts to 15 parts, because this ratio doesn't represent the amount of stickers that they necessarily have, but how many parts they have of the total amount. So we're told that Ibrahim has 24 more stickers than Matilda. But if we look at the ratio, Ibrahim has 8 more parts than Matilda. So what we can say here is that if the 8 parts must be equal to 24 stickers, because we can see from the ratio that Ibrahim has 8 more parts than Matilda, and we've been told in the question that he has 24 more stickers. So 8 parts is the same as 24 stickers. That means that 1 part must be 3 stickers. 1 part doesn't have an S on the end. 1 part must be 3 stickers. Okay, st for short. Okay, so now we also know that Ibrahim has more stickers than Rosie, and we want to know how many more. Well, firstly, let's work out how many more parts he has. Well, Ibrahim's got 15 parts for Rosie's 4 parts, so Ibrahim has 11 more parts than Rosie, and if 1 part is 3 stickers, then 11 parts must be 33 stickers more. All right, let's take a break there. That's the end of part 1. We will carry on with the next 5 questions in part 2 of this video series. In the meantime, let us know if you enjoyed this video by hitting the like button. If you have any questions at all, you can drop those in the comments and we'll do our best to get back to you. Don't forget to subscribe to our channel, Sums of Anarchy, for more maths tips and tricks, and we'll hopefully see you in the next video. Bye.